Okay, let's do an example of distance versus displacement. So say you have a clock, it has a 30-centimeter diameter, and picture the tip of the second hand as being your object. So, you know, my object is located here, let's say at the 12 right now. If you let 1 minute pass, so the second hand makes a complete rotation and gets back to the 12 again, what was the displacement of the tip of the second hand during that process? And what was the distance during that process? Okay. So the displacement over 1 minute is simply 0. The reason why is because remember that the displacement considers only the initial state and the final state, period. So over the course of 1 minute, the second hand makes a complete loop around the clock, gets back to where it started. The initial state and the final state are exactly the same. So as a result, it hasn't moved at all. The initial state and the final state are the same. There's no difference between them. So it doesn't matter that it moved between the initial and final state. The displacement is still 0. And by the way, just as a little factoid, if you have 0 magnitude on a vector, it doesn't have any direction because 0 doesn't, it's not pointing in any direction. So 0 is sufficient there. Okay, how about the distance traveled over 1 minute? The answer here would be that you actually have to look at the path that the object takes as it goes around. So it would go all the way around the perimeter of the clock like this and make a complete circle. So that means the distance traveled in 1 minute is going to be equal to, let's call it D, is equal to the circumference of the circle. And that is going to be pi times the diameter, because the diameter was given here. So, oops, there we go. So it's going to be pi times the diameter of the circle, which is 30 centimeters or 0.30 meters. So you would do pi times 0.3, and that gives 0.94 meters. Okay, so the displacement is 0, the distance traveled is non-zero in that case. What about same question, but this time we only consider a 30-second process. So the object starts at the 12, and the ending state, I'll switch to red again like I did in the other one. Okay, the ending state is down here. Okay, so it starts up at this 12, it ends up down at the 6. What is the displacement for that process? So first of all, remember what the displacement is. The displacement is a vector. Let me get rid of this. The displacement is a vector which points from the initial state to the final state, which means the displacement vector looks like that. You can see then the length of the displacement vector there is going to be the diameter of the clock. Okay, so displacement in 30 seconds is going to be equal to the diameter of the clock, 30 centimeters. Or I should more exactly say the magnitude is going to be equal to 30 centimeters. Remember, the displacement is a vector. So if you just answer this question by saying the displacement is 30 centimeters, that's actually not right because it's incomplete. That's the equivalent of, you know, somebody asks you for directions and you say it's 2 miles away. That's an incomplete answer. It doesn't actually tell you what happened. In this case, we need to specify the magnitude and the direction. So the magnitude of the displacement is 30 centimeters. The direction of the displacement would be the minus y direction, or down, or whatever you want to say. It points downwards from the 12 to the 6. because it points from the initial to the final. What about distance traveled in 30 seconds? In this case, we want to consider the full path, just like we did before. So we're considering not the length of that line, but it would be going from there to there around the perimeter of the circle. So that's going to be half the circumference of the circle. So it's going to be half of the answer we got before, which is 0.47 meters, 47 centimeters. Okay, so that's the distinction between distance and displacement.